Hello everyone, this is Mr. Eman. So today I would like to talk about the HKDSE sample paper, Mathematics Compulsory, Paper 1, Session B, Question 19. Please read the following message. This is the foundation of the series of this video. If you don't have enough time, please pause the video. Otherwise, let's go to the questions. The question is talking about circle, and we need to use circle properties. Here, I just make some lines for you to memorize the circle properties. For me, I will use 1, 2, 3, 4, 5 to memorize all the properties under circle. Okay, let's start with 1. 1 is the line, center cos distance. I will use this logic to help me to memorize the first two knowledge of circle properties. Because even or if even, then perpendicular. Line joining center and midpoint of chord, which is talking even, then perpendicular, perpendicular chord. If perpendicular, then even. Perpendicular line, now we have perpendicular. Perpendicular line from center, bisect cos. If perpendicular, perpendicular line from center, then even, bisect chord. Chord equal distance from center equal. Equal cos equal distance from center. You see, these four knowledge are all related to center cos distance here. Okay, if we have one line, this is the line I talk about is center cos distance. Two lines, we have an angle, and we always interested of angle at the center and an angle at the circumference. In fact, they are choice to each. They have a choice relationship. Angle at center choice angle at circumference. So angle at center is easy because it is formed by two radii. Angle at the circumference is formed by two cos, or should I say formed by three circumference points. A, B, C are circumference points. If I need to use angle at the center twice angle at the circumference, I will concentrate on 2 points A, B, because instead of shooting out two radii, it's also shooting out two cos. Okay. Angle in the semicircle. Now you can see A to B shoot out two radii, and there are two cos from AB too. Now we have two radii and two cos, and radii AO and OB, they are 180 degrees. If they are 180 degrees, two radii will become our diameter, and if we have diameter, then we have semicircle. Because the angle of the center is 180 degree, then the angle of the circumference is 90 degree. Okay, angles in the same segment. You can imagine there is our center O in this circle, and then we have two radii, and the angle of the radii must be 2 theta because the angle of the circumference is theta. As you can see, AB shoots two radii and shoots two cos to have the choice relationship. It is the same with angle at the center and the angle at the circumference about angle F. So it is also theta too. That means we have two angles are equals, and we say that this is angles in the same segment. Okay, remember the most important point in this case is also A and B because it should out each point should two cross out. All right. Okay, 3 lines, of course, we have triangle, and we have a golden triangle relationship between arc, chord, angle. And here I would like to remind you that chord is proportion to nothing. Only arc and angle are proportion. Alright? Arc length is proportion to angle at the center. Arc length is proportion to angle at the circumference. Okay? Because arc length calculation and angle at the circumference calculation are all based on angle at the center. 3 lines and circle properties we will think of cyclic quadrilateral. That means we have a quadrilateral inside the circle, and each vertex are circumference point of these circles. So if we have cyclic quadrilateral, the opposite angle adding up should be 180 degrees. And we also have the exterior angles of cyclic quadrilateral. They are equals. Alright, so on the other way around, if we have a quadrilateral and we find a pair of opposite angle adding up is 180 degrees, then we say that we have a quadrilateral, and so we have 4 circumference points, and we prove concyclic. This is the same idea in exterior angles equal interior opposite angle. For the converse of angles in the same segment, as I said, for just one or for an angle at the circumference, we have to use 3 circumference points. Okay, and then in the case of angles in the same segment, we always use 4 circumference points, and that's why when we have this kind of shape and then we have a pair of angles are equal, we can prove concyclic. 5 at last. I use 5 for at last. We have tangent. Tangents mean touch a point. That means a line touch a point of circle only, or a line touch circle at a point. In this case, the radius is perpendicular to tangent. Because of this, we can construct 2 congruent triangles with 2 tangents. As you can see, this pair of triangles in fact are congruent. Why? Now we have a pair of 90 degrees. We have a pair of lines, they are equal to each other because they are radii. And we also have one common line. Okay, 90 degrees stand for our right angle. And this common line is the hypotenuse of both right angle triangle, which is RH. And we also have a pair of sides they are equal, which is S. So we have RHS. In this case, the pair of angle at the center are equals. The pairs of angles at the meeting point M's are equal because of corresponding angles of congruent triangle. Again, the tangent PMs will be equal to the tangent QM because of corresponding side of congruent triangle. Now, in the angles in alternate segment, why they are equal? I just to help you to use this instead of giving you explanation here. Now, if we have a chord and tangent, we have an angle called tangent chord angle. And this chord has 2 circumference points. If it shoots to the other side of the segment to form a circumference triangle, the circumference triangle, the angle at the circumference is equal to the chord tangent angle. They are equal You have to memorize this because it is a very important, or it is very common knowledge of circle properties. So you may also use the converse of radius perpendicular to tangent and the converse of angles in an alternate segment to prove the existence of tangents. Because in question 19 part A, part 1, we have to prove congruent triangles. Let me give you a little bit reminder in here. Whenever we deal with the congruent triangle, we have two areas to deal with. One area is proof, the other area is to use of properties. It is the same in handling similar triangles. Also, as well as parallelized plus transversal. Okay, what is transversal? Oh, transversal is a line connecting to two parallel lines. You will see it later on. Okay, let's jump to the question. To prove triangle ABE is congruent to triangle ADE, first of all, we see what we have. We already have two lines, they are equals. AB equals AD because it is given. And AE equal to AE in these two triangles because it is a common side. And then what can we do? We connect C and D. Why do we need to do so? Connect C and D. We will firstly have to use the angles in the alternate segment. Now, if I say the chord tangent angle is theta, then I have an angle at the circumference which is theta 2 at point A, as shown in my arrow. At my arrow in here. Okay, and because this line is the transversal of the parallel lines, then I also have theta at D, which is alternate angles. Very good. And then we also use the angle in the same segment to prove that the other side of AE, or the angle BAE, is also theta. Then we have proved that there are two pairs of lines are equals and a pair of included angles are equal. Then these two triangles must be congruent. The reason is SAS. Okay, let's go to the 19A part 2. Before we answer the question, I have to help you to revise a little bit. Now, the four triangle centers, they are in center, circumcenter, central center, and orthos center. To construct in center, we need three angle bisectors. There is a meeting point of these three angle bisector, and this point is a center of inscribed circles, as you can see here. If we have three perpendicular bisector from the triangle, the meeting point, the center, will be a circumcenter, because I can use this center to draw a circle which just touch the three contacts of the original triangle. Median is a line joining the midpoint of a chord and the opposite vertex. And three medians, we will have a centroid. Okay. At the end, we have attitude, or should I say it is just a height of a triangle. And this three attitude or height will help us to find the orthocenter. Okay, cut it to short. When we talk about in center, we should have angle. We should remember angle bisector. Circumcenter, we will need 3 perpendicular bisector. Centroid, median. Orthocenter, attitude or height. So in the questions, we need to put whether these 4 center are collinear. I have to prove it to you that angle BEA is a right angle. Yes, of course you know that. Why? Because we can use the corresponding angle of congruent triangle and corresponding sides of congruent triangle to also prove that EB and ED. Okay. Now, as I said, AE is an angle bisector. Okay, in here you can see that. And AE is also a perpendicular bisector. And AE is also the median, because E is a midpoint and A is the opposite vertex, and AE is joining them, so AE is a median too. As angle BEA is 90 degrees, that AE is the height or attitude of this triangle. So I can conclude my answer in here. As an angle in center, circumcenter, centroid, and orthocenter are formed by angle bisector, perpendicular bisector, medians, heights respectively. At triangle ABD, AE is an angle bisector, a perpendicular bisector, a media, and a height. Therefore, in center, circumcenter, centroid, and orthocenter are collinearly on AE. This is the end of part A. Now, we go to part B. The part B would introduce some points. That is, A is 14.4, B is 8.12, D is 4.4. Okay. And we are asked to find the equations of PQ. So let me show you the linear equations logic structure. All linear equations are formed by actually slope. And from slope, we deduced 3 standard forms, which is helpful for us to find linear equations. They are slope point form, slope intercept form, and 2-point form. Okay, and in this coordination system, it is easy for us to find the slope of BD. If we can find the slope of BD, then we can find the slope of PQ, because they are parallel, and so their slope must be equal. And then we need to find a point. If we got a slope, then we need a point or intercept. In this case, I choose a point because in our case, it is not easy to find the intercept. A point will be relatively easier. How do we find a point on PQ? I'm going to find the point C on PQ. I'm going to find its coordinations. How? Okay. Because C and A form the diameter. Okay. If I can know the coordinations of this center, then I can use midpoint formula to find the coordinations of point C. How can we find the coordination of the center? Now look at here. We have to find h first. Because h is the midpoint of AD, so I can easily find the coordination of h. Now we are in the level 4. I always say that the y coordination actually is giving us the level. So it is on the level 4. The y coordinate must be 4. The h coordinate is not difficult to find because the h coordinate is just the middle of 4 and 14, which is, of course, 9. So I have already found you point x coordination. Again, because fh is perpendicular, so the x coordinate of the point center must be equals to 9 also. Then all our attention will focus on B. How do we find B? Now remember, OA is equal OD because they are radius. Then we can use distance formula to find B. And now we have the coordination of the center. So, as I said, I will use the midpoint formula to help us to find C and D. So I have shown it in the PowerPoint. And now we have to find the slope as shown here. And finally, we just pop the point CD and the slope 2 into the equations. We will have the tangent equation. Thank you very much for watching this video. If you have any problem, please feel free to email me at this email address. I have to say thank you so much because this is the end of this HKDSE sample paper series. Thank you and goodbye.